1 second. That's how long it takes to blink, to say the word okay, to do absolutely nothing. Now imagine freezing that second. Not for you, but for everything else. Every atom in the universe, every photon mid-flight, every spinning electron, every ocean current, every heartbeat. Stopped. You're the only thing still moving. Sounds peaceful. It is not. What happens in that frozen second, and what happens the moment time resumes, is one of the most violent scenarios physics is capable of producing. And the terrifying part isn't the pause. It's what comes after. First, we need to be precise. Time isn't a river with an off switch. It is woven into the structure of space itself. Matter, energy, motion. None of these exist independently of time. So when we say stop time, we mean this. All physical processes halt simultaneously. Molecules stop vibrating. Photons stop traveling. Gravity stops pulling. The nuclear forces holding every atom together stop acting. You are somehow exempt. You can breathe, move, think. The universe around you is a perfect statue. For the first half second, it might feel extraordinary, quiet in a way nothing has ever been quiet. Then you'd start to understand what you're actually standing inside. Your blood is frozen mid-flow. Your neurons are mid-fire. Every biochemical cascade keeping you alive is suspended. You're exempt. The moment time resumes, every process picks up exactly where it stopped. Heart, mid-beat. Neurons, mid-thought. 1 second of suspension, then life continues. Biologically, 1 second is nothing. Your cells don't notice. You'd feel a slight disorientation and move on. The problem is, everything outside your skin. Here's something almost nobody considers. Air isn't a calm, breathable arrangement of molecules sitting politely around you. It is constant, violent chaos. Gas molecules collide billions of times per second. They move at hundreds of meters per second in every direction. The reason you can breathe, the reason air behaves like air, is entirely because of that motion. Freeze it, and air doesn't become a peaceful, breathable soup. It becomes a rigid, motionless arrangement of particles with no thermal energy. For that 1 frozen second, you're standing inside what is effectively a solid. You can't inhale. You'd manage. 1 second of held breath is nothing. But the atmosphere itself has a much bigger problem. The atmosphere is not a passive layer of gas. It is a pressurized dynamic system held in shape by temperature gradients, planetary rotation, and gravity, all working continuously in real time. Jet streams moving at 300 kilometers per hour, high and low pressure systems mid-collision, storm cells mid-rotation, convection currents cycling heat between surface and stratosphere. All of it frozen. When time resumes, none of it returns sequentially. It all comes back simultaneously. Every pressure gradient reasserts itself at the same moment. Every wind current jumps from 0 to full speed in no time at all. There is a word for what happens when pressure differentials across massive air volumes collapse and reform at once. We call it a shock wave. What this would produce would circle the entire planet, multiple times. Any structure on the surface, buildings, bridges, anything with walls, would not survive the first pass. This alone ends the story for most life on the surface. But the ground hasn't done its part yet. The earth beneath you is under constant stress. Tectonic plates are always moving, always building pressure at fault lines. Stress that normally bleeds off gradually over decades through minor quakes and slow creep. Volcanic reservoirs accumulate thermal energy over centuries. The mantle convects. The core spins. When you freeze all of that, you are compressing a spring. Every fault line on Earth snaps back at once. The Cascadia subduction zone, the San Andreas, the fault lines beneath Japan, Chile, Sumatra, Turkey, Iran, all of them, same moment. We have no magnitude scale for this. Our current scale stops being meaningful around magnitude 10. What this describes doesn't register on it. It would simply be the ground moves everywhere, at once, releasing a century of accumulated stress in a fraction of a second. The oceans fare no better. Every current, every tide, every wave with kinetic energy mid-motion reasserts itself simultaneously. The oceans don't gradually flood coastlines. They arrive at them.
Here's something quieter, but worth understanding. Every piece of technology humanity depends on assumes time flows continuously. GPS satellites stay in precise orbit because their onboard computers are constantly making micro-corrections based on real-time positional data. Freeze time for 1 second, and every correction queued up during that second is skipped. The satellites don't know a second passed. To them, the universe simply jumped. The accumulated navigation errors from a 1-second universal pause would put GPS positions off by hundreds of meters. Every aircraft using automated navigation, every ship in port, every self-driving system, instantly compromised. Power grids are worse. The alternating current that runs every power grid on Earth oscillates at a precise frequency, 50 or 60 times per second, depending on where you live. The entire grid is synchronized to that rhythm. A 1-second freeze breaks that synchronization across every connected node simultaneously. Grid operators call a loss of synchronization a cascading failure. What this would cause doesn't have a name yet. Most of this is academic, though, because of what the sun is doing.
The sun is a fusion reactor held in balance by two forces in constant dynamic tension: the outward pressure of nuclear fusion and the inward crush of its own gravity. They never stop pushing against each other. That equilibrium is what makes the sun stable. Freeze both forces for 1 second, and the balance breaks. Gravity wins, briefly. The sun compresses, just slightly, and when fusion resumes, the imbalance produces a burst of energy propagating outward through the corona. It would not destroy the sun, but it would produce a coronal mass ejection at a scale we have no model for. Something between the Carrington event of 1859, which knocked out telegraph systems globally, and a scenario that would require new terminology entirely. The ejection reaches Earth within 24 to 48 hours. Every unshielded electronic system on the sunward side of the planet is destroyed. Not damaged, gone.
Under normal conditions, light from the sun takes 8 minutes to reach Earth. At the moment time stops, there is an enormous column of photons mid-journey through space. Light from distant stars, some of it traveling for millions of years, suspended in transit. When time resumes, every light source in the observable universe delivers its payload simultaneously. Not just sunlight, starlight, galaxy light, billions of years of in-transit energy, all arriving at once. The sky doesn't brighten. It becomes a wall of energy.
Let's count what's now in motion. The atmosphere has shockwaved across the globe. Every fault line on Earth has released its stress simultaneously. Every ocean has collided with every coastline at once. The sky has absorbed an impossible energy dump, and a solar event is 48 hours away that will end the electrical age of human civilization. 1 second. That's all it cost.
Here's what makes this genuinely strange. The destruction isn't from the frozen second. It's from the return. Energy is never destroyed. It waits. Every motion you halt is a debt. Every dynamic system you suspend is a spring you're compressing. The universe doesn't forget what was in motion. It defers it and collects everything at once the moment time resumes.
This is actually the same principle that makes neutron star collisions so violent. The universe does not do gentle returns from frozen states. It does full repayment immediately. Stopping time for 1 second is not a pause. It is a promise. And the universe, in its 13.8 billion year history, has never once forgiven a debt. Which means the most interesting second you could ever experience would also be the last interesting second anything on Earth ever would. That's not a reason to stop asking the question. It's the best possible reason to keep asking it.
The bird survived. Barely. If this video didn't destroy your brain, hit like. Subscribe. We have more questions the universe really doesn't want us asking.